Hello students, welcome to the class. So in the previous class, in the previous video, we have completed with the concept on classification of elements and periodicity in properties. We have seen how the periodic trends occur in the periodic table, right? So if this is our, let me say, if this is my periodic table, I can represent the periodic table like this, correct? So this is our periodic table, right? And we know that in this periodic table, as you move across the period, what happens to the periodic trends, and as you move down the group, correct? So this is what we are going to see now. Yes, we'll brief out and then we'll start our discussion with the multiple choice question. So if you see across the period, atomic size increases. Yes, atomic size decreases across the period. With the decrease in atomic size across the period, and here we know atomic size increases. Based on this character only, based on this atomic property only, rest all periodic trends are dependent. Rest all the periodic trends are dependent. Therefore, what I say, atomic size, as you go from left to right in the periodic table, atomic size decreases. Therefore, ionization energy increases. Ionization energy increases. Electron gain enthalpy becomes more and more negative. Becomes more negative. Electronegativity, it increases, or electropositivity, it decreases. Metallic character decreases, or non-metallic character increases, correct? Acidic nature of oxides. Acidic nature of oxides increases, or basic nature of oxides decreases. So this is all we have seen across the period. Vice versa is for atomic down the group. When you move down the group, since atomic size increases, ionization energy decreases. Electron gain enthalpy becomes less negative, or more and more positive. For this side, it is more positive. Electronegativity decreases, or electropositivity increases. Then metallic character increases, or non-metallic character decreases. Acidic nature of oxides decreases, or basic nature of oxides increases as you move down the group. So these are the variations in the periodic table. And all these what I have written with red ink, they all are dependent upon our atomic size. They all are dependent upon the atomic size. So with the decrease in atomic size, a nuclear attraction increases, due to which the electron, to remove the electron, we need to put more amount of energy. Therefore, we say ionization energy increases. Electron gain enthalpy becomes more negative. More negative means what? Large amount of energy gets released. And when energy is released, for that we say the process is said to be exothermic. When the process becomes exothermic, gaining the electron process becomes exothermic when electron is being gained by an atom very easily. And when the atom gains the electron very easily, when its atomic size is small, nuclear attraction will be more. Nuclear attraction will be more. Therefore, it gains the electron very easily. So it becomes more and more negative. So for metals, electron gain enthalpy is positive. That means forcibly you need to put the electron. That means you have to give energy. The electron absorbs energy to go into the atom. Yes. Non-metals, it is heavily negative. Highest electron gain enthalpy is for chlorine. It is for chlorine. Delta electron gain enthalpy is highest for chlorine, most negative. Yes, it's not for fluorine. We'll discuss in one of the questions also. Why is this so? Why is it so? Then electronegativity, it is the property of non-metals. So across the period, non-metals metallic nature increases. Therefore, electronegativity also increases. Most electronegative is fluorine. As you move down the group, electronegativity decreases, and the least electronegative is what? Is cesium. It is cesium. So opposite of that is electropositivity. Across the period, electropositivity decreases. Down the group, electropositivity increases. Most electropositive is what? Electropositive is cesium. Again, it is most electropositive. Yes. And when we speak about all these trends, we speak up to group 17. Group 18 is considered differently. They are studied differently. Okay. Then metallic character, non-metallic character, acidic nature of the oxides, basic nature of the oxides come under chemical properties. They come under chemical properties. So metallic nature means what? It is the tendency to lose electrons, and that is nothing but reducing property. So reducing nature of the metals, it decreases across the period, and reducing nature of metals, it increases down the group. As you move down the group, it increases. Non-metallic character is the tendency of gaining the electrons. Therefore, we say it has oxidizing character. Oxidizing character. Therefore, non-metallic nature increases across the period. Therefore, oxidizing nature increases across the period. And as you move down the group, since non-metallic character decreases, oxidizing character also decreases as you move down the group. And this is about oxides, the oxides which are formed. Metals combine with oxygen to form oxides which are basic in nature. Non-metals combine with oxygen to form oxides which are acidic in nature. You know the examples: Na2O, K2O, CaO, MgO. These are all metallic oxides. CO, CO2, SO2, SO3, NO2. These are all non-metallic oxides. So metallic oxides are basic in nature. Across the period, since metallic character decreases, basic nature of the oxides also decreases. Down the group, since metallic character increases, basic nature of the oxides also increases. In case of non-metallic oxides, which are acidic in nature, across the period, non-metallic character increases. Therefore, acidic nature of the oxides increases. As you move down the group, non-metallic character decreases. Therefore, acidic nature of the oxides also decreases. So this is about the periodic trends in physical properties and chemical properties elements of elements in the periodic table. Periodic trend in the physical and chemical properties of the elements in the periodic trends. So with brief concept of this concept map, what we have discussed, we'll move to the first question. Identify the correct match. Un, nil, un, ium. Un, nil, un, unium. It is for which of the elements? So we know this is what? This is the IUPAC suggested nomenclature. For 0, we represent it as un. For 1, for 0, we represent it as nil. For 1, it is un. For 2, it is bi. For 3, it is tri. For 4, quad. For 5, it is pent. For 6, it is hex. For 7, it is sept. For 8, it is oct. For 9, it is n. Correct? So they have given us un, nil, un, ium. So it is un, nil, un. So it is 1, 0, 1. Then second one, un, nil, trium. So un, nil, tri. So it is 1, 0, 3. Next, un, nil, hexium. Un, nil, hexium. So 1, 0, 6. Then un, Aniyam. Yes. So aniyam. 111. Yes. So these are the elements. And I've told you when I was discussing about this particular concept, I've told you above 100, atomic number above 100, this systematic format of nomenclature is being given by IUPAC, where we follow these routes. So the atomic number only we substitute all these root words and write the name for the element until its discovery is proved. So 101 element from 101 up to 112, the discoveries are being proved. After 112 till 118, they are not yet proved, right? Therefore, 101 is called what? It is called Mendelevium. 102 is called what? It is Nobelium. 103, Lawrencium. It is an element of actinides. These two are the elements of actinides. 104, Rutherfordium. 105, Dubnium. 106, Seaborgium. Seaborgium. 107 is what? Borium. 108, Hafnium. 109, Meitnerium. 110, Darmstadtium. 111, sorry, it is unnil. It is what option given is unnilium. So it is 110. Unnilium is 110. 110 is what? Darmstadtium. 111, Röntgenium. 110, Copernicium. Yes. So let us see which is the correct match. Unium. UNU. So it is what? 101. Correct. So it is 101 is what? Mendelevium. 101 is Mendelevium. Unniltrium. 103. 103 is Lawrencium. 103 is Lawrencium. Then unnilhexium. Hexium is being given. Unnilhexium is what? It is Seaborgium. Correct. And anium. It is Darmstadtium. So A is 1, B is 2, C is 3, and D is 4. Yes. So they had to give the options here. So we write A is 1. All the 4 options are correct. Okay. Identify the incorrect match. I'm sorry. Unnion is what? Unnium is 111. And 111 is Ronchenium. Correct? But here they have given Darmstadtium, which is for 110. So this is the incorrect match. This is the incorrect match. Rest all are correct matches. Correct? So this is the incorrect match. Okay. So they have asked the incorrect match, right? Okay. Moving to the next question. The element Z with atomic number 114 has been discovered recently. It will belong to which of the following family, group, and electronic configuration? How do we write element 114? Atomic number of the element is 114. I need not sit writing it. Yes. Okay. So what is the electronic configuration of the element with 119? 114. The name is being discovered recently. It is flerovium. Yes, it is written as the nearest noble gas, helium, neon, argon, krypton, xenon. It is radon because this is 114. Yes, radon. We write it as 5F14, 6D10, 7S2, 7P2. This is the element electronic configuration of the element. So 5F14, 6D10, 7S2, 7P2. So outermost shell is this. This is the outermost shell and it is having what? It is having NS2, NP2. Can you see this? It is having NS2, NP2. NS2, NP2 is the configuration of which? So last electron is entering into p orbital. Last electron is entering into p orbital. Therefore, the element belongs to p block. Okay. Now, how to find the period? Period number It belongs to which period? It belongs to 7th period. So which principal quantum number is highest, that we'll consider. Group number. Yes. When it is for S and P are present, the total plus 10. Valence electrons plus 10. So 10 plus 4. It belongs to 14 group. Which is that? It belongs to carbon. It belongs to which family? Carbon family. 14. It belongs to carbon family. Yes or no? 13 is boron. 14 is carbon. So it belongs to carbon family. It belongs to carbon family and its configuration is this. Carbon family and its configuration is this. Is that right? Okay. Next, an atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. You will place it in which group they have said. So how do we find the group number? Just now I have told, if the outermost shell has got, look at the outermost shell. Okay, this is not the outermost shell. So I can write this electronic configuration like this. 1s2, 2s2, 2p6, 3s2, 3p6. First 4s electrons get filled, then 3d3. So here the last electron is entering into d orbital, so it belongs to d block. They have not asked us d block. There is highest n is equal to 4, therefore it belongs to 4th period. They have not asked us period also. But if you see the outermost shell, it has got d orbital, s and d orbital. So when it is only s orbital, you will write the total number of valence electrons is equal to group number. So how many valence electrons are there? That is the group number. If it is d or orbital in the outermost shell, the how many valence electrons are there? That is the group number. Total valence electrons. If it is p, then 10 plus valence electrons. Correct? Like this we go on. So it is d orbital. Therefore, how many valence electrons? There are 5 valence electrons. 5 valence electrons. Therefore, it belongs to which group? It belongs to 5th group. What is the name of the element? 10 electrons, 10, 20, 23. Scandium is 21, titanium is 22, vanadium is 23. The name of the element is also vanadium. It is vanadium. So it belongs to 5th group. Yes, it belongs to 5th group. So in the configuration, the last electron of the atom is filled in the d subshell. Yes, 3d3. Thus, element belongs to d block of the periodic table and the group number is total of these valence electrons. It is 5. Element is vanadium. Okay. Next, the electronic configuration of the element is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number of the element which is just below the above element in the periodic table? Okay. So the element given with electronic configuration is given 1s2, 2s2, 2p6, 3s2, 3p3. What is this element? This element is 6, 7, 8, 9, 10 and this is 3, 15. Correct? The element is 15, that is phosphorus. It belongs to which group? Since it is 3s, 3p, so 3 plus 2 is 5, so it belongs to p block. It belongs to 3rd period. It belongs to 15th group. Correct? It belongs to 15th group. Now, how to find the element? One thing is that you should be knowing the elements which come in a particular group. Lithium, first group. Sodium, potassium, rubidium, cesium, francium. Beryllium, magnesium, calcium, barium, strontium, barium, radium. Yes, and this side, P block, boron, aluminium, gallium, indium, thallium. Carbon, silicon, germanium, arsenic, antimony. Then boron, carbon, nitrogen, phosphorus. Then here we have below phosphorus, we have the element. Now the question is which is the element here, right? Which is the element here? Therefore, in such cases, what I suggest is either you should be knowing the element, which element is present, or you should be knowing the element, or you should be knowing the how to find the next element atomic number. So carbon, silicon, germanium, I'm sorry, it is not arsenic, it is tin here, and then here it is Pb, lead. Nitrogen, phosphorus, here it is arsenic, then antimony, then bismuth comes here. Bismuth. Oxygen, sulfur, selenium, tellurium, polonium. Fluorine, chlorine, bromine, iodine, astatine. Yes. Helium, neon, argon, krypton, xenon, radon. Yes. This is group 13, 14, 15, 16, 17, 18. Okay. Understand? You should be knowing the elements. But if you know the elements, can you tell the atomic number? Please do remember the magic numbers. If you know the magic numbers, you can predict the atomic number. For group period 1, after 2 elements, the period 3rd starts. That means the period 3rd starts with atomic number 3 and ends with atomic number that we know. It ends with atomic number 10. Correct? After that, I can write here, after that, the magic numbers 2, 8, 8, 18, 18 and 32. These are called the magic numbers. So what is given here? They have given this. How many electrons are there? 5 electrons. So it belongs to 15th group. Yes, it belongs to which group? It belongs to 15th group. So when it belongs to 15th group, I need to predict what? The next element. Atomic number is 15. Atomic number is 15. 6 plus 4 is 10 plus 3, 5 is 15. So I want to see which element is there below this element. Okay. So what I will do is, here it belongs to 3rd period. 3rd period. That means I have to add how many electrons more? How many atoms more? Sorry, how many electrons more? Plus 18 more. So when I add this, 18 plus 15, it is 3, it is 33. So the element which comes below, that is this arsenic element, it is having atomic number equal to 33. You can even verify it also. So the atomic number is 33. 33 is the atomic number. Okay. Next, if the atomic number of an element is 33, just now we have seen, it will be placed in which of the periodic tables. Now, if they give you atomic number, immediately write the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Okay, 33 they want. So this is 10, this is 10, 3d 10. After 3d comes what? After 3d comes 4p. 4p. 33 means 3 here, correct? 10, 20, 33. So the element atomic number is 33. Its electronic configuration is so. Okay. So it lies in what is the question? I can write it like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Can I write it like this? And finally 4s2, 4p3. So see, it is ns2, np3. 5 electrons. So it falls in which group? 15th group. It falls in 15th group of p block elements. So which is 15th group? It is nitrogen family. Nitrogen family. Even you can predict the element also. 33 just now. It is arsenic. Yes, it belongs to p block. It is present in 4th period and belongs to 15th group. And the element name is arsenic. Symbol is arsenic. Correct? So it belongs to which group? It is 15th group. It is 15th group. It should be 15th group here. Okay, fine. The electronic configuration of 4 elements are being given below. Which elements does not belong to the same family as others? So if we want to say, do they belong to same family, means what? They should belong to same group. When we say the elements belong to same group, when they have same outermost electronic configuration. Yes, when the outermost electronic configuration is same, they will belong to same group. Observe option A. It is xenon 4f14, 5d10, 4s2. So outermost configuration is having 4s2. S2 electrons are there. Next, krypton 4d10 5s2. Outermost shell has 5s2. So s2 is there. Here neon 3s2 3p5. S2 and P is also there. So NS2 NP is also there. In case of last option, AR 3D10 4s2. Yes, so there is again only 4s2 configuration. Therefore, option A, B and D, they are having the outermost electronic configuration with two electrons, with two valence electrons belonging in S group. Two valence electrons belonging in S orbital. Yes, in the valence shell. In contrast, if you see element C, it has 7 electrons in the valence shell. It has got 7 electrons in the valence shell, whereas option A, B and D, they have 2 electrons in the valence shell. Hence, it lies in other group. This will lie in the other group. Is that clear? So you have to observe where the valence configuration or valence electrons are same. If the valence electrons are same or valence configuration is same, it belongs to the same group. But if the valence configuration is different, it belongs to different group. Next, for the second period elements, the correct increasing order of first ionization energy is. Okay, good question. Across the period, atomic size decreases. Therefore, nuclear attraction on valence shell electrons increases. Therefore, ionization energy, they've said first ionization, so I'll take first ionization energy, also increases. Okay, they have taken second period elements. Second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so atomic number is 3, 4, 5, 6, 7, 8, 9, and 10. So expected is lithium has got least ionization energy, then comes beryllium, boron, carbon, nitrogen, oxygen, and fluorine. Correct? This is the correct expected one. So across the period, atomic size decreases, so ionization energy increases. But if you observe the configurations of all these elements, this is 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, 1s2, 2s2, 2p2, 1s2, 2s2, 2p3, 1s2, 2s2, 2p4, 1s2, 2s2, 2p5, 1s2, 2s2, 2p6. Okay. So if you observe, what happens is, in case of beryllium and boron, in case of beryllium and boron, beryllium has got outer shell as S and it is having 2 electrons, so it is completely filled. Whereas boron is having outer shell P and it is having 1 electron. Therefore, what we say, beryllium will require more energy to lose its electron from the stable alpha or completely filled configuration. Therefore, the change becomes, I will write the change. The change becomes lithium is having lower energy, lower ionization. It requires lower ionization energy. But among beryllium and boron, boron will have lower energy than beryllium. Okay. And it continues again. Carbon. Okay. Now, if you observe for nitrogen and oxygen, configuration, if you see for nitrogen, it is in the p orbital, spin up, spin up, spin up, 3 electrons. Whereas for oxygen, it is spin up, spin up, spin up, spin down. So in case of nitrogen, it is having half-filled orbital configuration in the outermost shell that becomes extra stable. Therefore, to remove the electron from half-filled requires more energy than compared to oxygen. Therefore, oxygen will have lower energy, ionization energy than nitrogen. So oxygen will have lower ionization energy than nitrogen. Then comes fluorine and last will be what? It will be neon. So lithium then boron, then beryllium, carbon, oxygen, and then nitrogen, fluorine, and neon. So which supports this option? That is the correct option that appeared in 2019 recent NEET exam. So which is the correct option? Lithium, first boron, okay, beryllium, carbon, first oxygen, then nitrogen, fluorine, and then neon. So correct option is option C. It is option C. Next question. The question is not printed properly. I'll read out the question. In which of the following options the order of arrangement does not agree with variation of the property indicated? So I is less than Br is less than Cl is less than fluorine. What is the property? Increasing electron gain enthalpy. Okay, electron gain enthalpy of iodine is less than boron, which is less. Less means what? It is less negative than chlorine, which is less negative than fluorine. Lithium, here metallic character. The metallic character of lithium is less than sodium, it is less than potassium, it is less than rubidium. Okay, I will write here. It is not correct. Please observe, it is less than rubidium. Okay. Then increasing ionic size. Al plus 3 has smaller ionic size than Mg plus 2, which is having smaller ionic size than Na plus, which is having smaller ionic size than F minus. Increasing ionic size. Then option D, boron atomic size is greater than greater than carbon, which is greater than nitrogen, which is greater than oxygen. That is atomic size. So which is not correctly matched. Okay, let us take first option. Let us take first option. So what first option says? I, electron gain enthalpy of iodine is less than electron gain enthalpy of bromine, which is less than electron gain enthalpy of fluorine, which is less than electron gain enthalpy of fluorine. See, these are halogens, fluorine, chlorine, bromine, iodine. And we know that halogens have got very high negative values of electron gain enthalpy. As you move down the group, what happens? As you move down the group, why they have got very high negative value? Because atomic size is small. So fluorine atomic size is so much. As you move down the group, atomic size increases. So when atomic size increases, the negative value decreases. Correct? So which should have highest electron gain enthalpy? This should have highest gain enthalpy. Yes, this should have highest electron gain enthalpy. So the correct order, but if you see in chlorine and fluorine, if you consider chlorine and fluorine, this is the correct order. It is least here. But actual answer is electron gain enthalpy of iodine is less than electron gain enthalpy of bromine, which is less than electron gain enthalpy of fluorine, that is less than electron gain enthalpy of fluorine. So electron gain enthalpy is most negative for chlorine, not fluorine. Electronegativity is highest for fluorine, but electron gain enthalpy is most negative for chlorine. The reason is, if you see fluorine, this is the atom, let me see, of fluorine, and this is the atom of chlorine. So if you see fluorine, this the electron has to be gained here. In this case also electron has to be gained. So what you say, since atomic size is small, electron will be gained very easily. But what happens, because of the smaller atomic size, the electron-electron repulsions become stronger. The electron-electron repulsions become stronger. Yes. So electron-electron repulsion in small sized fluorine atom. In small sized fluorine atom is more. So because of this repulsion is more, if the gain electron will not be gained that easily. I'm not saying you have to put energy here. No, it is negative only. But it will be not gained that easily. That means that much amount of energy will not be released. Whereas in case of chlorine, since chlorine is having slightly larger atomic size than chlorine, there will be less electron-electron repulsions. Electron-electron repulsions will be quite less. Therefore, electron will be gained very easily. So, I say electron gain enthalpy is more negative for chlorine than electron gain enthalpy of fluorine. That is also negative only, but it is less negative than chlorine. So this is not correctly matched. Second option, increasing metallic radius. Lithium, sodium, potassium, rubidium. As you move down the group, atomic size increases. So this is the correct order. Lithium is having smaller atomic size, then sodium, then potassium. Next option is what? Third option is Al plus 3, Mg plus 2, Na plus, and F minus. So these are what? They are all isoelectronic ions. They are isoelectronic ions. Yes. So increasing ionic size. We know that in isoelectronic ions, as the charge, as positive charge on cation increases, atomic size decreases. And as negative charge on anion increases, atomic size increases. So which is having highest positive charge, that should be written first, that will have least atomic size. Then comes Mg plus 2, then comes Na plus, and in anions this comes last. Understanding? Yes, this comes last. So this is also correct. And atomic sizes across the period. Boron is having more atomic size than carbon, which is having more atomic size than nitrogen, which is having more atomic size than oxygen. So first one is the incorrect match. Fluorine electron gain enthalpy is less than chlorine. Yes, that is incorrectly matched. Next, match the oxide given in column with its property. Sodium oxide, aluminium oxide, nitrous oxide, oxide of nitrogen, chlorous oxide. Okay. See, in oxides, we have 4 types of oxides. I had just told you about metallic and non-metallic oxides. Metallic oxides are basic in nature. That means metallic oxides react with acids to produce salt and water. They undergo neutralization with the acids. Non-metallic oxides, so they will react, metallic oxides will react only with acids. Non-metallic oxides are acidic in nature. So non-metallic oxides will react with bases to produce salt and water. I can quote examples also for this. Metallic oxide, which one will take? Sodium oxide. It will react with acid, HCl, and forms NaCl plus H2O, 2NaCl, 2HCl. Non-metallic oxides react with bases. Non-metallic oxide, say carbon dioxide, react with bases, NaOH, will form Na2CO3 plus H2O, salt and water. Understanding? But there are some metallic oxides, say metallic oxides of aluminium, zinc, and all, they are both basic and acidic. That means they react with acids as well as bases. For example, I'll write here aluminium oxide, Al2O3 reacts with acid to form AlCl3 plus H2O. You can balance it later. Al2O3 reacts with base NaOH to form NaAlO3, sodium aluminate, Al2O3 plus H2O. Such oxides are called amphoteric oxides, which have both acidic and basic character, amphoteric oxides. And there are some non-metallic oxides. There are some non-metallic oxides, say oxides of carbon and oxide of nitrogen, which are neither acidic nor basic. They are what? They do not react with acids nor bases. So they are neutral oxides. They are called neutral oxides. Example, carbon monoxide. Carbon dioxide is acidic. In carbon also, not all oxides. Carbon dioxide is acidic. N2O is neutral. Yes. So we have in oxides. Under oxides, we have 4 types. Basic oxides of metals, acidic oxides of non-metals, amphoteric oxides of metals, of some metals, and neutral oxides of some non-metals. Okay, now let us see what is the question given. They have asked sodium oxide is what? Sodium oxide is basic oxide. So first one is B. Aluminium oxide is amphoteric oxide. Second one is D. N2O is what? N2O is neutral oxide. Third one is A. Last one is what? Cl2O3. It is an oxide of non-metal and it is acidic. It is acidic. It is C. So first one is B, second one is D, third one is A, fourth one is C. D is the correct option. So under oxides, we have four types of oxides. Metallic oxides are basic. Non-metallic oxides are acidic. But some metallic oxides like aluminium oxide and zinc oxide, they are react with acids as well as bases. They are said to be amphoteric. Some non-metallic oxides, say non-metallic oxides of carbon, carbon monoxide, nitrogen, nitrogen oxide, they are neither acidic nor basic, so they are neutral. They are neutral. Okay, so this is the correct match. Option D is the correct match, right? Which of the following oxides is most acidic in nature? Magnesium oxide, beryllium oxide, barium oxide, calcium oxide. See, in case of these are all metallic oxides. We know that metallic oxides, as you move down the group, basic nature of metallic oxides increases. Correct? Basic nature of metallic oxides increases. So in case of metals, on moving down the group, why basic nature increases? Because metallic character increases. So basic nature of the oxides as you move down the group increases. So beryllium, magnesium, calcium, strontium, barium we have. So basic nature is increasing down the group means what? This is more acidic. So which becomes more acidic? This is more acidic. More acidic. Then we have beryllium, magnesium oxide, which is actually amphoteric. Then we have calcium oxide, strontium oxide. It is not given here. Last is barium oxide. This is highly basic. Yes, as basic nature increases down the group, the top ones are acidic in nature. Therefore, this is most acidic, beryllium oxide. And that is the anomalous behavior of beryllium. We have discussed anomalous behavior of first element of each group. Yes, next. Which of the following orders of ionic radii? Which of the following orders of ionic radii is correctly represented? Is correctly represented. H minus, H plus, we know that, and H, Na plus, F minus, O2 minus, F minus, O2 minus, Na plus, and none of these. Okay, they have considered in the first option, they have considered about hydrogen. In the second, third options, they have taken Na plus, F minus, O2 minus. So all both the options, these are taken. Okay, hydrogen, we know that a cation is always smaller than its atom, and we also know that an anion is always larger than its atom. Correct? This is what we know. This is first case. Second case, if you look, they are isoelectronic ions. Just now we have discussed. In case of isoelectronic ions, when you write the order, increasing order, first cation with greater charge comes, with greater charge, then cation with less charge, then anion with less charge, because in case of isoelectronic ions also this rule follows, and then anions with larger charge. Okay, hydrogen H minus, H plus. So cation is having smaller size, then comes neutral atom, and then comes anion. So this is having larger size. Correct? Atomic size. This is having smaller atomic size. Okay. In case of isoelectronic ions, which is having smallest atomic size, Na plus is smaller. Then comes F minus. and then comes O2 minus. Okay, so which option is given? Let us see what is the question they have asked. Orders of ionic radii is correctly represented. Is this correctly represented? No, this is not correctly represented. Na plus comes first. Is it greater? No, it is wrong. It should be in decreasing order. It is less, increasing order. Okay. Here F minus 2 is given. Is it greater? No. O2 minus 2 comes first. Yes. Then, therefore, option is what? None of this. Because cations lose electrons and are smaller in size than the parent atom, whereas anions gain electrons and are larger in size than the parent atom. So for H, this, which is a correct match, H minus is having greater atomic size. Then comes hydrogen. Then comes H plus ion. For isoelectronic species, the ionic radii decreases with increase in the atomic number. So, because nuclear charge increases, hence the correct order is O2 minus is having greater atomic size, ionic size, then comes F minus, and then comes Na plus. Na plus. So, none of these is the correct option. None of these has the correct order of ionic radii correctly represented. Correctly represented. Next question. The formation of oxide ion O2 minus from oxygen atom requires first an exothermic and then endothermic steps as shown. Okay, oxygen gaining an electron, it will gain very easily because atomic size is less. Therefore, it is negative. O minus, once it gains electron, it forms, and this is endothermic. Okay, let us see what is the question asked. Process of formation of O2 minus in gas phase is unfavorable even though O2 minus is isoelectronic with neon. It is the fact due to. It is the fact due to. The option is O minus ion has comparatively smaller size than oxygen atom. Oxygen is more electronegative. Addition of electron in the oxygen results in larger size of the atom, ion. Electron repulsion outweighs the stability gained by achieving noble gas configuration. So process of formation of O2 minus in gas phase is unfavorable even though O2 minus is isoelectronic with neon. Okay, what is the reason? See, if you see here, once O2 minus is formed, how O2 minus is formed? When two electrons are gained by oxygen. So what happens there? There is electron-electron repulsion. Of course, there is electron-electron repulsion. Okay, so because of this, what happens? O2 minus will have larger size. That also should be considered. So O2 minus will have larger size. When O2 minus is formed, oxygen atomic number is 8, 1s2, 2s2, 2p6, correct? When O2 minus 2 is formed, gain of 2 electrons, 1s2, 2s2, 2p8. So it has achieved the noble gas configuration. Though it has achieved the noble gas configuration, O2 minus in gas phase is unfavorable, they say. What is the reason? Because in neon, there is no electron-electron repulsion. Neon has got 10 electrons, whereas if you see, okay, I'll explain it very properly here. If you look in case of oxygen, its nucleus has 8 electrons. But if you take oxygen O2 minus, its nucleus has 8 electrons. Sorry, its nucleus has 8 protons, whereas there are 10 electrons. In case of neon, its nucleus has 10 protons. In case of neon, its nucleus has 10 protons and it is having 10 electrons. So this positive charge is distributed to 10 electrons. But here, this positive charge has to be distributed to 10 electrons. So nuclear attraction is less on these 10 electrons, whereas the nuclear attraction is uniformly distributed to these 10 electrons. Understanding? Though O2 minus has gained the stable configuration of nearest noble gas, that is neon, it is still unfavorable because the nuclear attraction becomes less. Why it becomes less? Because of the electron-electron repulsion. Because of the electron-electron repulsion. So electron-electron repulsion outweighs the stability by gained by achieving noble gas configuration. So option D is the correct option. Option D is the correct option. Okay. So understood why option D is correct. That becomes the correct option because electron-electron repulsion is there. Whereas in neon, there is no electron-electron repulsion. Already it should have 10 electrons, it is having 10. With oxygen, by gaining 2 electrons, there is electron-electron repulsion, which outweighs the stability of nearest noble gas configuration. In which of the following arrangements the given sequence is not strictly according to the property indicated, against it? Okay, let us see. HF, HCl, HBr, HI, increasing acidic strength. H2O, H2S, H2SE, H2TE, increasing pKa values. NH3, PH3, ASH3, SPH3, increasing acidic character. CO2, SiO2, SnO2, PbO2, increasing oxidizing power. See, these are mineral acids. Yes. As you move down the group, look at these are non-metals. Halogens. As you, okay, let me consider it here. We'll consider all the 4 options and see which is not correctly matched. Okay. Option A, HF, HCl, HBr, and HI. Okay. So as you move halogens, as you move down the group, metallic character in any case, when you move down the group, metallic character increases. Yes, metallic character is increasing means what? Basic nature increases. So as you move down the group, it is in decreasing order. So which is most acidic? This is most acidic, correct? And this is less acidic. So is it increasing or acidic strength? Yes, that is correct. Second case, H2O, H2S, H2SE, H2TE. These are elements of group 16. Oxygen, sulfur, selenium, tellurium. Increasing pKa values. pKa, dissociation constant of acid. Yes. And as you move down the group, acidic nature decreases. So this will have large pKa, less pKa value. Lesser the pKa value, more is the acidic strength. So here it is having less pKa value. As you move down the group, pKa value increases. Correct? So here I say acidic strength of hydrides. These are all. I'll do it like this better. We'll take it like this. Acidic, whatever options are given, strength of hydrides, they are all hydrides of different group elements, increases with increase in molecular mass. And as you move down the group, molecular mass increases, correct? So if you look first option, HF, then HCl, then HBr, and then HI. This is correct. In case of second option, H2O, H2S, H2SE, H2TE. In case of third option, NH3, PH3, ASH3, and SBH3. Okay. As acidic strength increases, pKa values decreases. Thus, order of pKa for all of them, if I want to write, I will write it as HF is having less pKa value. So as acidic strength increases, pKa value decreases. So HF should have less pKa value than HCl, less pKa value than HBr, less pKa value than HI. H2O, this is more acidic, right? H2O should have less acidic. Here, less acidic. So it should be like this only for pKa. Less pKa value than H2S. It should have less pKa value. It should go on in this order. Understanding? As acidic strength increases, pKa values decrease. Therefore, the pKa values correct order is this order. So this pKa value is more. In our given option, it is less than H2S, less than H2SE, and less than Te, tellurium. Therefore, that is the wrong option. B option is wrong. And in case of carbon dioxide, silicon oxide, in case of oxides, as you metallic oxides are reducing, non-metallic oxides are oxidizing. As you move down the group, metallic nature increases, therefore oxidizing nature decreases. So this is more acid, more oxidizing. This is less. As you move down the group, reducing nature comes. So that is the correct order. Only B is not the correct order. Okay. Identify the wrong statement in the following. Amongst isoelectronic species, smaller the positive charge on cation, smaller is the ionic radius. Amongst isoelectronic species, greater the negative charge on anion, larger is the ionic radius. Atomic radius of elements increases as one moves down the first group of the periodic table. Atomic radius of the elements decreases as one moves across from left to right in the second period of the periodic table. This is correct. When you move across the period, atomic size decreases. This is also correct. When you move down the group, atomic size increases. Amongst isoelectronic species, greater the negative charge on the anion, larger is the ionic radius. That is also correct. Therefore, for anions, how we write? M minus 3, larger ionic radius, M minus 2, larger ionic radius, than M minus 2, than M minus, and then M. Amongst cations, M plus 3 will have smallest ionic radius than plus 2, which will have smallest ionic radius than plus 1, which will have smaller ionic radius than M. So amongst isoelectronic species, smaller the positive charge, smaller is the ionic radius. No, amongst isoelectronic species, larger the positive charge, smaller is the ionic radius. So this is the wrong statement. Option A is the wrong statement. So that is the wrong statement. Is that right? Next question. What is the value of electron gain enthalpy of Na plus if first ionization energy of Na is 5.1 electron volt? So they have given first ionization energy. Ionization energy means what? From neutral gaseous atom, you have to put certain energy called first ionization energy. Then it will lose one electron and becomes an ion, cation. So they have said the electron gain ionization energy of Na is 5.1 electron volt. And they have asked what is the electron gain enthalpy of Na plus. Na plus, electron gain enthalpy of Na plus means what if it gains one electron? What is the electron gain enthalpy when it gains one electron to become Na? What it will be? It will gain the electron very easily. Yes, it has become Na plus. It will gain the electron. Then delta electron gain enthalpy will be what? It will be the same as ionization energy. How much energy you are putting to remove the electron, the same amount of energy will be released when it gains the electron. Yes, so it will be same amount of energy released. Therefore, it will be what? Minus 5.1 electron volt. Energy will be released when it gains the electron. So minus 5.1 electron volt is the correct option. Yes. Which of the following oxides are amphoteric? Amphoteric oxides means what? Oxides which react both with acids as well as bases. Carbon dioxide is an oxide of non-metal and it is acidic in nature. It will react only with bases. Silicon oxide is also what? It is acidic in nature. It will react only with bases. Therefore, I can say carbon dioxide and silicon dioxide, they are acidic oxides. They will react only with bases. Calcium oxide is a typical metal oxide. It is basic in nature. Whereas stannous oxide is amphoteric in nature. It will react with acids as well as bases. I can show you the reaction also. Stannous oxide reacts with acid to form salt and water. Form salt and water. So SnCl2, H2O. So two oxygen atoms have to be balanced. So I'll write 2 here, 2 2s are 4. I'll write 4 here and this becomes SnCl2. Correct? Plus 2H2. instance Cl4 plus 2H2O. Even stannous oxide reacts with base, that is NaOH, to form again salt Na2SnO3 plus H2O, sodium stannate. So balance it. So here I will write Na2SnO2. So therefore it will balanced by writing 2 here. So such oxides which react both with acids and bases to form salt and water are said to be amphoteric oxides. Amphoteric oxides. And the oxides which neither react with acids nor bases, they are said to be neutral oxides. So here which is amphoteric? It is SnO2. It is amphoteric in nature. The correct order of decreasing ionic radii. The correct order of decreasing ionic radii among the following isoelectronic species. As I said, with the increase in atomic charge, with the increase in positive charge, atomic radius, ionic radius decreases. With the increase in anionic charge, ionic radius increases. So Ca plus 2 greater, it is which is greater here. So which anion is having greater charge? S minus 2 is greater than Cl minus. Then positive charge with less charge, K plus and Ca plus 2. So this will have the correct order, decreasing order of ionic radii. So this will have biggest ionic radius and this will have smallest ionic radius. Anions are always bigger amongst the isoelectronic ions, and ionic radius increases with increase in negative charge. Why? Because effective nuclear charge decreases. Similarly, ionic radius decreases with increase in positive charge because effective nuclear charge increases. Therefore, this is the correct match. Which of the following represents the correct order of increasing electron gain enthalpy with negative signs for elements oxygen, sulfur, fluorine, and chlorine? See, if you see, immediately we say this, we say that as we move across the period, oxygen, below oxygen is sulfur, fluorine, below fluorine is chlorine. So as we see, chlorine atom has got highest electron gain enthalpy in the periodic table. Yes, fluorine being the first member of group 17 has higher electron gain enthalpy than sulfur. So if you observe, it is oxygen, sulfur, fluorine, chlorine. So amongst this, chlorine is having highest electron gain enthalpy. That means it is having more negative value. Okay, why? Because just now I have told, since atomic size of chlorine is slightly more than fluorine, electron-electron repulsions are less, whereas here electron-electron repulsions are more. So here large amount of energy will be released. Then comes fluorine. If you consider fluorine and sulfur, which is more? Fluorine is more. After fluorine, which comes? Sulfur comes, and then oxygen. Understanding? So chlorine has the highest electron gain enthalpy in the periodic table. Fluorine, being a family member of group 17, has highest electron gain enthalpy than sulfur, which belongs to group 16. Yes. Thus, this in turn is higher than the electron gain enthalpy of oxygen. So in this case also, if you see, sulfur has more electron gain enthalpy than oxygen. Again, same reason, because of the atomic size. Yes. So it is worth noting that electron gain enthalpy of oxygen and fluorine, the members of second period, have less negative values of electron gain enthalpy than corresponding elements of sulfur and chlorine of the third period. Why? This is due to the small size atoms of oxygen and fluorine. As a result, there are strong electron-electron repulsions when extra electron is added to these atoms. Therefore, electron gain enthalpy or electron density is high and addition of extra electron is not very easy. Therefore, which is the correct option? It is more negative for chlorine, then comes fluorine, then comes oxygen, then comes sulfur. Yes, then comes sulfur. So increasing electron gain enthalpy, it is in this order. Least negative, more negative, negative. This is less negative. So this is the correct order. No, it is in decreasing order. Okay. So this is the correct order. So this is having less negative value, then comes the sulfur, then comes fluorine, and last comes chlorine. Observing this. So correct option is what? Option B. Yes. So with this, we'll discuss the next questions in our next slide. Hope you have followed all the questions so far what we have discussed. Next questions I'll be discussing in the next slide. Thank you.